Hi, welcome to the Metal and Wood Shop. We're located in room 1211 at the Student Innovation Center. Here, we have some important safety protocols that we need to follow. We have a line here, and you have to have the proper PPE or personal protective equipment to cross this line. What we require in this shop is closed-toed shoes and closed-heeled shoes, long pants, and safety glasses. If you have long hair, it's a good idea to tie it back. Long sleeves, you should pull them up. Also, remove any loose or dangling jewelry such as watches, necklaces, and rings. And if you have strings on your sweatshirt, tie them or tuck them in. We ask that you scan in on our card readers and tell us why you're here. On our website, you can find a list of restricted materials, so as you're planning a project out, you know what you can and can't use. All of our tools in the shop have a designated safety level, and those levels correspond to the level of supervision that they need and the risk those tools provide. We also have everything locked, so when you come in, you need to talk to a shop supervisor and get that tool unlocked so that you can start your project. We look forward to seeing you soon. This is the mill, found in room 1211, the Metal and Wood Makerspace, and room 0235, the Heavy Metal Makerspace at the Student Innovation Center. This machine is used to shape metals, plastics, and other materials by cutting them. It can be used manually or as a CNC machine. It operates as a 3-axis machine, able to move along the X, Y, and Z planes. This machine does not perform turning operations or cut internal features. It does not work well with thin metal or sheet metal. We do not have the proper dust collection and guarding to mill composite materials like carbon fiber, fiberglass, or other materials. This is a safety level 3/2 machine. This means that as a new user, a supervisor must be available to directly supervise machine use. Once you are a trusted and established user, a supervisor is only needed to supervise setup and initial startup. It then becomes a safety level 2. This means that in order to operate, 2 trained users must be present. This can be 2 trained friends, a user and a makerspace assistant, or a user and a shop supervisor. Material prep. Cut your material down to a manageable size using a saw if needed. There are lots of fixtures available for a wide range of materials. Consult a makerspace assistant or shop supervisor for help with material fixturing if you are unsure. Buttons and switches. This is the X-axis table move handle. This is the Y-axis table move handle. This is the Z-axis spindle move handle. This is the table height adjustment handle. This is the pneumatic tool changer controls. This is the spindle power and direction switch. This is the spindle speed dial. These are the 2 emergency stops. Use these if there's a suspected issue or you need to stop the machine quickly. Machine setup and operation. Getting comfortable with the machine is the most important part of operating this machine. The X-axis, Y-axis, and Z-axis are controlled by these handles, and it can each move in 2 directions. Your first step should always be to start by moving the table so that the space below the spindle is open and free for material, vices, or other debris. Our mills use a collet tool holder system. There's a graphic on how to change tools available, or you can consult a makerspace assistant or shop supervisor. You may get experience with this in the hands-on training. There are a variety of tools available for milling. We will outline some of the most common ones. These 2 are end mills. They are used for most operations on a mill and will cut and remove material on the sides and the bottom. They are razor sharp and should be handled with care. The 2 main versions are flat end mill and ball end mill. This is a facing mill or shoulder mill. It is used to square and flatten large areas on top of the material. It is helpful when trying to clean up rough stock. This is a Jacobs drill chuck. It is used for holding drill bits when wanting to use the mill to drill holes. It operates the same as the chuck on the drill press. This is an edge finder tool. It is used to locate the edges of your material and set up a reference point for milling. You will get more experience with most of these tools in the hands-on training. Once you have your tool loaded into the collet and tool holder, you will then load it into the machine. We will load the edge finder to start with. To do this, you will hold the tool holder around the collar. Never hold it by the tool or cutting edge. Then insert the tool holder into the spindle opening on the machine. You will want to align the tabs on the spindle opening with the cutouts on the tool. Reach up with your other hand and gently press the in button on the pneumatic tool changer controls. Start with very light pressure and slowly increase so that the tool is slowly drawn up into position. Once the tool is aligned, press the button fully to properly seat the tool. Listen for the hammering noise to ensure proper torque. You can now let go of the tool collar. At this point, you're going to use the edge finder to set your reference point or datum, which you will receive more instruction during the hands-on training. You're going to want to put the protective shield in place, and then to manually start the spindle, turn the spindle power switch in the forward direction and set your speed using the speed dial. There are online calculators for speeds, charts on the machines, or you can consult a shop supervisor. Once you have your edge found, you can change the tool out for a cutting tool. Load your cutting tool, start the spindle, and use the X, Y, and Z axis handles to complete your cut. Cleanup. Vacuum or sweep up all of the chips and shavings. Metal chips are sharp and should never be cleaned up with your hands. Use a brush to brush off the tools if they are dirty. Dispose of any scrap in the appropriate bin. Wipe off any coolant or oil off the vices or table surfaces.